Graham's Law of Effusion. In a gas mixture composed of two ideal gases, the particles of each gas will have the same temperature and therefore have the same average kinetic energy. However, their velocities will differ due to differences in their masses. So we have kinetic energy 1 equals kinetic energy 2. Those are the two different gases. Substitute in our kinetic energy formula that hopefully we learned from physics. Multiply both sides by 2, and then do a little cross multiplying so we can get the relationships of the velocities and the masses. Take the square root of both sides, and you have v1 over v2 is the square root of m2 over m1. We have an inverse square relationship between mass and velocity. We have here three gases and their molar masses, which you get from the periodic table, and their average velocity of the gas particles at 27 degrees Celsius. Please note this is not a linear relationship. Helium is only 1/8 the mass of oxygen, but it travels at only the square root of 8, or 2.8 times the speed of the oxygen particles. Effusion is the escape of gas molecules through a tiny hole over here into an evacuated space, which is down here. The rate of effusion for helium is higher than that of nitrogen because its mass is lower, so its particles move faster. They then escape the balloon faster, deflating it. These two balloons were initially filled to the same volume, nitrogen and helium. After 48 hours, the balloon filled with helium was smaller. Graham's law of effusion states that the relative rates at which two gases will effuse is inversely proportional to the square root of their molar masses. This is due to effusion being proportional to average velocity, which is inversely proportional to molar mass. How much faster would we expect hydrogen gas to move as compared to nitrogen gas? Here's our molar mass of nitrogen and the molar mass of hydrogen. We start with Graham's law of effusion, and then we solve for VH over VN, where H represents hydrogen, N represents nitrogen. And then we substitute in the givens, and we multiply both sides by V sub N because we're looking for the velocity of hydrogen compared to the velocity of nitrogen, and we get velocity of hydrogen is 3.742 times the velocity of nitrogen. Notice the 4 sig figs throughout the problem. Therefore, hydrogen will travel 3.742 times faster than nitrogen, so their relative rates of effusion would be 3.742 to 1. An unknown gas travels at a rate that is 0.85 times the average velocity of oxygen gas in the same mixture. What is its molar mass? We are given the velocity of an unknown gas, which will represent as V sub U, is 0.85 times the velocity of oxygen gas, which is VO. So we start with Graham's law of effusion. We never like dealing with square roots in equations, so let's go ahead and square both sides. We have this. We now solve for the mass of the unknown gas, so it will be V of oxygen squared over V of unknown gas squared times mass, molar mass of oxygen. We substitute in our givens. Here's the velocity of oxygen squared, and the velocity of the unknown gas is 0.85 times the velocity of oxygen, so we put that there. And then we have our molar mass of oxygen, which we get from the periodic table. Carry out the math, and the molar mass of the unknown gas is 44 grams per mole.